Are you ready for the energy transition? Hello, good afternoon. My name is Dario Rigo from Fluor. Thanks for joining today. During this breakout session, we'll talk about energy transition and advanced water packaging. We want to address this common concern. Does AWP have anything to do with energy transition? Isn't AWP about oil and gas only? Well, we'll talk we have prepared an agenda to cover this, and we'll talk about global energy transition, Fluor's role within this energy transformation, advanced for packaging, some elements of Fluor's AWP implementation. Before getting into subject, let me tell you a bit more about me. As I said, my name is Dario Rigo. I'm a senior construction support engineer and a mechanical engineer with over 17 years of experience. I have been working in capital projects execution the whole time. The last 7 years, I have worked on this giga project. It's an oil field expansion located in Kazakhstan. I keep an active role within the Construction Industry Institute. I'm part of the joint working group on AWP data requirements. I'm also working on the research team 391, defining opportunities to leverage artificial intelligence, machine learning, and data analytics applications for AWP. I'm also a participant of the European construction industry, AWP Community of Practice Europe. Last but not least, I speak Spanish, so yes, yo hablo español. In case you want to chat in Spanish later about AWP. Let's begin with global energy transition. As you know, there is a global energy sector shift from fossil-based systems of energy production and consumption, including oil, natural gas, coal, to renewable energy sources like solar, wind. The world is decarbonizing the current um, energy mix to reduce the greenhouse gas emissions. Achieving net zero emissions by 2050 are a huge challenge. They will require nothing short for the complete transformation of the global energy. The United Kingdom, as a global leader, already has a strategy. The net zero strategy is Build Back Greener. Targets are quite challenging. We expect to decarbonize the power system by 2035. There is a global consensus on the urgency and the need of the scope of the capital investments required. However, as you would imagine, this energy transformation also comes with some challenges. The capital project sector faces unprecedented challenge in 5 areas. One of them is speed. The project sector will need to transform the work and the decision processes to enable these net zero projects to move faster through the investment decision stages. It will also need to reimagine the design and construction methods to improve productivity and reverse that decline in productivity trends. The second challenge has to do with predictability. Practical and financial, political and financial stakeholders will expect predictable costs and schedule outcomes from these investments. So to do that, that's a huge challenge since unfortunately the project delivery system has a long history of unanticipated costs, overruns, and delays. The next challenge has to do with technology. New decarbonization technologies are advancing rapidly, but it also makes the whole thing more complex, complex to engineering, to construction, and operations. So the industry will need to transform its processes for maturing technology. The next challenge has to do with capacity and collaboration. As you would imagine, supporters of this net zero project portfolio will likely spend every part of the project delivery to have the right people, skills, uh, owners, operators, and EPCs all working together. So it will require changes in terms of collaboration, even organizational transformation, if you think about it. And the final challenge that I want to highlight today has to do with safety and the environment. Despite the increased need for a speed in project development and delivery, there is also a need and high standards for safety and performance that we cannot compromise. More than that, now we need to think about reducing the carbon footprint and reducing emissions during the whole project execution. So as you can see, markets are shifting and global priorities are being realigned, but the underlying need to optimize project delivery remains. Fluor's role within this energy transition has to do with safely and sustainably design, build, and maintain projects that create a better world. To do that, and to uh, help clients to navigate their decarbonization journeys, we focus on different sectors. One of them, renewables. In terms of renewables, um, fluor fabrication assets plus our EPC capabilities provides a unique platform to enable large-scale offshore wind projects. To do that, we can bring our expertise to OSW projects, so offshore wind projects, in two areas, offshore fabrication as well of offshore fabrication of the wind turbine, as well as this um, EPC delivery of the whole offshore substation. These, for this, we will use our legacy supply chain, construction management, and commissioning expertise, so we can provide overall project management approach to this type of OSW projects. The next area would be carbon capture. This can happen post-combustion combustion and pre-combustion. With regards to post-combustion, we already have patents, technology patent that is capable to, through enhanced solvents, formulations to lower emissions and waste production. So we already can offer clients a menu of advanced energy reduction configurations that can be selectively implemented into any plant design. With regards to pre-combustion, we also have fluid solvent that can be utilized in high-pressure pre-combustion processes to capture CO2. It has years of operating experience and it offers many advantages, such as no heat required for regeneration of solvent, production of a dry treated gas, and a tolerance of varying CO2 levels. The next area I would like to highlight are the small modular reactors. For the small modular reactors at Fluor, we work with NuScale to offer these nuclear solutions. This is about carbon-free energy small modular reactors that are the advanced reactor with an electrical output of less than 300 megawatt electrical per module. This provides significant benefits in terms of safety, reliability, scalability over traditional nuclear power plants. Small modular reactors have advantages in cost and schedules, Uncertainty that are suitable for situations where larger reactors are not practical. And the final element or area that I want to touch today is hydrogen. We understand this energy transition is driving change in the energy sector. Hydrogen will play a significant role in the decarbonization of the global economy. Fluor's patent process for hydrogen recovery provides a cost-effective method for recovery with simultaneous byproduct of LPG recovery, utilizing a compact skid-mounted system. Our role is to provide solutions to reduce carbon emissions and improve sustainability. To do that, we need to look now to our project delivery strategy. This is based on our proprietary zero-based execution. This process allows us to simplify design for our clients and provide them with facilities that run effectively on a linear wheel. Zero-based strategy is about reversing the conventional project development paradigm. It is based on the philosophy of formally and directly aligning the design premise with project goals before design execution, not after, and bringing the economic needs of the project into design phase before the design begins. These zero-based requirements are the minimum requirements for the facility to work, to be safe, legal, operable, and to meet the output needs, recognizing capital efficiency requirements, and there is a clear and deliberate addition to of any cost of an scope, with items only added if they improve the business case. It's a very interesting concept, but if you look at this slide, one of the elements and one of the strategies that we use to improve project delivery is advanced work packaging. And that's what we're going to talk next. Advanced work packaging traditionally contractor face why? Because traditionally contractors face reward and low productivity due to both insufficient planning and poor coordination between the project functions, leading to cost overruns and missed scheduled targets. Implementing advanced work packaging helps us to correct this and consistently create predictable results, reducing and eliminating rework, improving schedule performance, safety, efficiency, and overall quality. So, and when we do that, we get other benefits like incorporation of the turnover system requirements, visual identification through the construction automation tool, increased visibility of the incomplete scope at the work fronts, reducing wall down times and punch list items. As you can see, by implementing advanced for packaging, Fluor has successfully been able to improve time on tools. And today, I would like to draw your attention to three elements of our Fluor AWP implementation. The first element, construction-driven execution. Second, WBS work breakdown structure integration with the construction work areas, construction work packages, and IWPs. And third, AWP data requirements. Let's begin with construction-driven execution. Advanced work packaging and the overall philosophy of early involvement in project development is a key tenet of Fluor project execution strategy, and it's all about begin with the end in mind. So operations determine the sequence for commissioning and startup, and we use that information to define to have our turnover and commissioning team to define a sequence that will then drive construction. With that information, construction will work into developing the path of construction and construction work areas, This will drive engineering and project controls to set up the WBS. We're gonna talk more about that in a minute. Then engineering will produce the construction work packages according to the construction priorities. As I was saying, engineering will produce the construction work packages according to the construction priorities. And then construction will take the CWPs to develop the installation work packages, or IWPs. These IWPs will be executed in the field, and then when bulk construction progresses, we'll carry on with switching from bulk construction to systems completions driven execution. Finally, we'll commission by systems and hand over to operations for the startup. Operations startup plant in sequence. It's all about beginning with the end in mind and design to construction to production. As you can see through this approach, we actually take our planning efforts even beyond beyond construction because we take into consideration that build to completion outlook, which is key and part of our construction driven execution strategy. Also, something that I wanted to highlight is the plot plan development and constructability as key elements for the path of construction and construction work areas. During early FEED, the plot plan served as the most tangible compilation of project physical scope and is the effective root document for future AWP efforts. The plot plan will be developed through continuous engagement and will have the engineering team and construction input, and we need to make sure they take into consideration safety, design, and constructability elements such as site logistics and access, site topography and drainage, modularization, times, how to work through density, construction contracting strategy, heavy haul and heavy lift, procurement, material, module supply and delivery constraints, as well as consideration of system completions, overall turnover sequence, and plant startup. So fit plot layout is adopted as the basis for subsequent AWP steps. The input to the plot plan will be gathered through formal reviews and interactive planning sessions where all parties are able to provide and discuss input based on specific hard constraints, requirements, or previous experience. And this is very critical. It's adopted, as I said, this is adopted as the basis for subsequent AWP steps. It should be noted that the plan development process is iterative. As the information becomes available during feed and design development, further refinements can and will be made to the plot, depending on the assessment and net impact of any change or alteration. The path of construction, as I said previously, will be the basis for sequencing engineering design, procurement, and fabrication, module assembly, construction, and completion, and will form the basis for the Level 3 EPFC schedule. The next element of this Fluor AWP implementation that I want to discuss today has to do with the WBS integration and the work packaging structures. So as we all know, AWP fundamentals which come from a plant is broken down into construction work areas, geographical areas, continuing into construction work packages, discipline specific, leading then to installation work packages, which are developed by workers planner. We all know that. Um, but in terms of how do we take that and put it into our WBS and in the way that we then we're gonna report, and execute the project. So the way that we do that is by defining different levels. So in order to define our execution WBS, typically what we got first are the units. Units is the higher level of the WBS, and it will be followed by our CWAs, and the two of them together will define the physical location. So, and this is important for us when defining the WBS, making sure the first two levels together define a physical location. Then, as you would imagine, the next level is the construction work package. And the construction work package is a portion of the WBS that will contain the description of work. And finally, because all of this becomes our execution WBS, and of course it will evolve during the different project phases, will be the basis for the development of installation work packages or IWP definition. To, to put it in a different way and make this clearer, so we're talking here about smart coding, the way that we code our WBS. So typically the first levels would be the units, as I said, higher level units, group of units. It has to do with the different reference plant types that we may have. It's typically managed by project controls. Um, and then the coding will continue, will expand to the CWA with the geographic boundaries to determine the physical location. And this work is done between engineering and construction. Typically, they need to look at together based, as I said, CWA is done to be a result of the path of construction. So our WBS coding expands to including the CWAs in there, and we'll continue with the CWP. And the CWP level is the one that is going to have more details about the work, about the execution. So that's how we know is it fuel installed, is it module, is underground, what the discipline is this for concrete, for steel, for electrical, for piping, uh, it's very important to make sure the construction work packages are in alignment with the contracting strategy. And you might think on the CWPs as the vehicle to organize drawings and materials. Because in the end, what we want is these construction work packages to ensure that has we want to ensure these CWAs and this CWP will help ensure the home office deliverables support the construction planning efforts. So it will be the home office deliverables and the material deliveries. So that's the WBS, and then from that we'll continue the work packaging during the workforce planning phase, and we'll have in this level typically an identification of the type of work, type of IWP, if we might say. So just to know if it's a fabrication IWP or an IWP for actual installation at site or for testing. There is typically a sequence in there as well. I guess what I'm trying to highlight with this second element of the Fluor implementation is the importance of having a WBS that was thought from the beginning in a way that will work with word packaging in the end. In the past, we have faced challenges due to WBS not easy to align with the word packaging strategy. It makes the whole execution more difficult. So this is a very important step for us, making sure we get a WBS that actually supports the workforce planning efforts coming later on, or the whole construction execution. The third element that I want to discuss today has to do with AWP data requirements. What you see on the screen is very similar to construction-driven execution. Plan the work, work the plan. About plan the work, We see system completions driving the path of construction, defining the construction schedule based on construction work areas, and that information will fuel the fabrication, will fit the fabrication schedule, different interconnections that we may need, the supply chain schedule, the material deliveries, material planning, and the design schedule, model reviews, and deliverables. So that's all the plan, the work phase. That's the construction-driven execution phase. And then we come to the bottom part of this diagram. We see there unit plan, CWA, CWP, IWP, and something in red there very important, data requirements. Because that's where you define it. And that's how you define it. When you plan your work and you look at everything that you want to do and it's driven uh, by construction in this case, that's how you define all the requirements that you're going to have later in the project, but you need to do it early. So it's very important to have data requirements clearly defined at the beginning of the project. So then, when we work the plan, we ensure that our systems and our data support this process. Therefore, we have a construction schedule that drives engineering deliverables and material deliveries, and we have CWP releases that support IWP preparation, and all this information is available through our systems and the data that we have created and maintained throughout the project execution. In terms of AWP data requirements, I would like to highlight that within Fluor, we have our own data set or our own data requirements and specification. Um, and it was basically created thinking on supporting workforce planning packaging strategy. And the elements that we thought would be beneficial to begin with were rules of credit, materials interface, document interface, completions interface, schedule interface, and 3D model. So these are the main six elements that we thought would be beneficial to get to know what data construction requires upfront to support the workplace planning and the packaging strategy in these six areas. So we had meetings with different disciplines, subject matter experts, key process owners. We gather all the information and we release our own document, our own Fluor's data requirements document. But then CII, Construction Industry Institute, did something very similar. They did something very good with input from the academia, owners, EPC suppliers, technology providers. They did a work based on digital threats and defined a CII AWP data requirements developed by a joint working group, which is available to everyone and is free of charge. So you can go right now, go to that link, and you'll find this document in there. AWP data requirements from CII have all the data required for all the elements that you can see on the screen. This phase, uh, I wouldn't say a challenge, but this was a good opportunity for us as well internally to see if the work that we did actually aligned with what the industry did as well. And that's exactly what happened next. So we did some work, and this is a summary of our journey. So we had our Fluor AWP data requirements based on project experience, based on Fluor people. Then CII published the AWP data requirements in September of 2020 by joint working group. Between 2020 and 21, we actually had we did a review and a cross-reference alignment between our data requirements and the CII published AWP data requirements. And then last year, December last year, CII published the first revised version of the first update based on industry feedback. And right now, again, we are in an ongoing review process of the data requirements that we got and see what else we can do to improve. Perhaps what I'm saying here and what I would like you guys to take away from this is as Fluor, we have our own data requirements, some ways to probably do, um, because this is something relatively new and each company has gone their own way trying to make things work. But now we see industry is getting to some consensus and developing these documents like the AWP data requirements, which by the way, as I mentioned, I'm also part of the joint working group. Um, and I think it has been a really good experience that I will definitely recommend to anyone because it gave me, it gave us in general, to all the participants, the opportunity to be part of the discussion. Be part of the discussion has tremendous values. There is value. There is people in there from multiple companies, different representatives, different viewpoints about this general and common process, which is transfer packaging. But being part of the discussion allow us to find ways, to make this a industry data requirement better, but also um, they understand also others people viewpoints, and and find more common ground to improve project execution, which is in the end the goal we all have. So let's continue. When we review AWP data requirements, as I said, we wanted to know how different they were with regards to what we had. Um, the next couple of slides, I just want to highlight what you will find in AWP data requirements. Honestly, what we found wasn't too different to what we actually had, because in the end, when you execute any piece of project, you are looking for the same. Sometimes you didn't use same names, but in general terms, you follow and you have similar goals. So and goals like this. So what kind of information you will find in there? Well, you'll find information in there to plan and define installation work packages. So typically, a planner will want to know what's the priority, what's the plan. So to do that, there is a schedule section in there with attributes like CWPs, activities, dates. Typically, a planner will want to know, well, what do we put into this AWP? To do that, to go to the requirements, you'll find different reference there for equipment, 3D models, civil, electrical, piping, and the requirements are quite common, are CWPs, proper tagging, dimensional attributes, engineering attributes, and it's applicable pretty much to every single object, like foundations, spools, equipment, cables, instruments. Also, um, interfaces, which has to do with removing constraints. So a planner will want to know, well, what drawings do I need to execute this work? So you find in the data requirements a section dedicated to drawings, documents to register, revisions, documents to CWPs, tags, um, also for materials. So in there you'll find CWPs, tags, PSMARTs, POs, required outside date. Also, you'll find in there information related to estimating and progress. So you want to know how much I have progressed by this work. So you'll find information related to rule of credit, CWP, work type, and as we said, that link with system completions, which is very important. So you'll find in there a section for system completions and data required is just CWP, IWP, subsystem, tags, cheat sheets. So when you start to look at a bit to the details, you'll notice it's not very different to what your projects might be needing or looking for. So it's really worth checking and take a look to what the data requirements have. Because in the end, data requirements will give us some benefits. Will give us the ability to have dashboards and reports, as well as a streamlined interface for better collaboration. Will also allow improved visibility of the current status of the project. Will help us to make informed decisions, data driven, as well as unlock all the potential behind data analytics. So when you got your data requirements in place and your data available, you can do lots of things with it. In the end, all these efforts will help productivity, predictability, cost, and schedule. So let's take a step back and look at the AWP outcomes in general. So what 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 is the what are the benefits of this AWP implementation? So one of them has to do with lean schedules and reduce costs. Another one has to do with increased cost and schedule predictability. That's what we do with AWP. Also, from AWP, we get effective data-driven decision making. That's quite important. Also, we get improved collaboration because AWP is not just for construction, it requires engineering, procurement, fabrication, construction, suppliers, all on the same table. And of course, it helps to increase safety and reduce waste because even if think about it. When we set lean schedule, so we finish early, so that's less waste and reduce carbon footprint if you think about it. And if you look at these outcomes in details and think for a moment on the challenges that I mentioned at the beginning of the presentation, you may find they are quite similar. And actually, those challenges, when you implement AWP, are no longer challenges. They become opportunities because AWP will address each one of these challenges that I already mentioned. And in the end, there is just a huge opportunity to take these to to help that big challenge, which is the energy transition and this sustained construction activity that is required for the next year to achieve those net zero targets. So, in summary, we have discussed today global priorities realignment. Yes, we understand that it's a change. Um, We understand markets chief come with challenges. Not that easy. We mentioned the five of them. We also talk about Fluor's role to provide solutions. We talk about the different AWP elements or AWP implementation elements within Fluor, construction drawing execution, WBS integration, data requirements. And finally, we talked about the outcomes of the benefits of implementing AWP. They actually address the energy transition challenges. So if you look at what we have discussed today, well, there is just one conclusion, which is what I want to share with you today, and I want you to take away. Think on AWP, think on energy transition driven by AWP. Think on these net zero targets reinforce the need of optimizing project delivery, and AWP offers a proven project execution approach, which addresses fundamental energy transition challenges by safely and sustainably optimizing project delivery. improving productivity and predictability in cost and schedule to meet markets and stakeholder needs. Thank you.